All right, hi everyone. So we're going to look at solving modulus inequalities today. And there are some very important rules that you must remember. And we have to apply these rules, especially when we're dealing with inequalities. Yeah, we don't really apply these rules for modulus equations, but only specifically for modulus inequality. All right, so rule number one, if the modulus of P is less than or equals to Q, then what we'll say is that P must be between minus Q and Q. All right, so this is a less than situation. Okay, now how does it look like graphically? It looks something like that. If we have a modulus, let's say something like that, and Q is a line right here. So when we say less than Q, we are actually looking at the answers here. That's why it's between these two particular situation. All right. Now, same thing if modulus is more than or equals to Q, then we will have this scenario instead, where we are looking at the fringes, right? So that's why P must be more than or equals to Q, or P is less than or equals to negative Q. All right. So these two rules, we will apply it very frequently as we look at the examples below. All right. Okay, let's look at example 1. We have modulus 2x minus 1 is less than 3. So this is exactly the scenario where we have mod P is less than Q, right? So we will recall that this is between minus Q and Q. So we're going to apply it in this scenario. So therefore we say, therefore we say 2x minus 1 is less than 3, and it is more than minus 3. Okay, so this will be the scenario. We're going to add 1 to both sides of the equation. So this will be minus 2 will be less than 2x, will be less than 4, and we're going to divide both sides by 2. So x will be between negative 1 and 2. Now, let's just test it out to see if it's true. So a number that is between minus 1 and 2 is 0. So we're going to sub x 0. So 0, so minus 1 is less than 3. Yes, that is true. 1 is less than 3. Okay, so this range of answer would basically be correct. Okay, so I hope that's clear. Now, graphically, how it looks like is basically this. It's going to have a modulus graph, and 3 is right here, y equals 3, and we're looking at these two intersection, which is minus 1 and 2. Yeah, not very accurate, but you get my point, yeah? So we are looking at the answers right here, the range of x values, okay? All right, so let's try example 2. Mod 2x plus 3 is more than 4. So this is the scenario where mod P is more than Q. So we know that P must be more than Q and P must be less than negative Q. So we're going to apply this for this particular question. So we're going to say 2x plus 3 must be more than 4, or 2x plus 3 must be less than minus 4. So we're going to clean this up. So x will be more than half, and x will be less than minus 3.5. Okay, so we're going to test it out to see if it's true. So any number more than half, let's say 1, for example. So 2 times 1 is 2 plus 3 is more than 4. That is true. Okay, so this would be true. Let's test a number less than minus 3.5. Let's say minus 4. So mod minus 8 plus 3, is it more than 4? Yes, it is more than 4. This is also true. Okay, so both is true. All right, so this will be how we apply the rules in this situation. All right, now let's look at the third example. Now, if we have a modulus with a modulus and it's an inequality, there's not really a rule where we can apply, mod P is less than Q or something like that. We can't do that. Now, the only method, the only way we can do, the only way is for us to square both sides. Okay, that is really the only option that we have. We don't really have any other options. All right, so let's square both sides. What will we have? Let's see. So 2x plus 1 square will be more than equals to 3 minus x square. Now we're going to square both sides. We're going to have 4x squared plus 4x plus 1 more than or equals to 9 minus 6x plus x squared. Okay, we're going to bring everything to one side. We can clean it up. So that will be 3x squared plus 10x minus 8 will be more than or equals to 0. So we can probably factorize that. So 3x, x, 3x squared. We have maybe a 4 somewhere. 4 minus 2, minus 8. Yeah, that might work. So we have 12x minus 2x, 10x. Let me add it. Yep. All right, so I'm going to rewrite as 3x minus 2, x plus 4 is more than or equals to 0. Now, once we reach here, it's very convenient to say 3x minus 2 is more than 0 and x plus 4 is more than 0. We can't actually do that. Now, if you recall, this is actually the situation where we apply triple S, right? We want to look at how the graph looks like quadratically. We want to look at the roots. In this case, it's -4 and 2 by 3, and we want more than 0. We're looking at the fringe, okay? So therefore, our answers has to be x has to be less than or equals to -4, and x will be more than or equals to 2 over 3, okay? So that's how we solve this. All right, so I hope this is a good introduction to how you solve modulus inequalities. So there are various methods, especially for the mod p less than q and mod p more than q, we will use the rules. And if it's 2 modulus in an inequality, we just kind of want to square both sides. Now, essentially, you do have to check your answers. I didn't check here, but you should check and make sure that the range of answers is correct. Sometimes part of the range is wrong. All right, so it's always a good habit to check, and I should practice that. Let's do a quick check anyway. So x less than -4, let's do -5. So mod -5 would be -10 plus 1. Is it more than or equals to mod? This will be 8. Yes, that is true. Okay, so this is true. All right, x more than 2/3. Let's choose 1. So 2 times 1 is 2 plus 1. Is it more than or equals to 3 minus 1, which is 2? Yes, that is also true. So this is also true. Yeah. All right, so I hope this summarizes what we need to do to solve modulus inequality. Sometimes we can square both sides to make it quadratic, or we apply the rules. Okay? So that's all. I'll see you in the next one. Cheers.